All right, this is the February 4th CUP review for conditional authorization. Go for it, Lucas.
Yep. So yeah, if we start off by or kind of where we left last week. Let me see if I find this one. I think yeah, no, you should see my screen, I think, on the presentation. So yeah, just to summarize, nothing kind of new here, but yeah, just we want to make a subject access view kind of give us fast responses initially, and then especially we want to keep kind of um, the response like everything that can give us an unconditional response. We want to kind of see that and kind of just go through the normal flow for all of those things, which is probably going to be 95+% at least. Then always keep symmetry between in core, out of core. We do need to separate kind of no matter what we do, the notion of like, can this ever become allowed? If it's a conditional, can it ever become allowed? Or um, or is it always kind of either a deny or no opinion that it produces? Or can it become anything, so allow, deny, or no opinion? Um, so that we at phase one can know kind of when seeing the first conditional response that, okay, should we continue kind of checking for, is there something that can become allowed, or are we good kind of short circuiting here and then continuing later? By default, authorize does not support conditions the caller needs to opt in some way, and not all of them um, opt in. Um, and there's I'm making a list of that, like, or the cap already has updated basically with the list, but I'm just gonna add also like the specific code references of like the packages that call authorize, so it's easier for people to kind of find them. Um, and then yeah, we add a new always built-in validating admission controller that then kind of picks up whatever was left to do from phase one, and then resolves those with the actual state that we get. Um, then whatever we do needs to work well with aggregated APIs over existing caching layers. A chain that is formed as a DAG, so like you can have, for example, node authorizer to call to the kubelet call to the API server, which calls to some other set of webhooks that could call further webhooks and similar. But as long as it's a DAG, it's okay. Um, the versions queue into count, connect requests, and then compound authorization for stuff that kind of moves within the request chain. So all of those are good. The authorizer, and to recap, the authorizer needs to never it cannot output a conditional response unless a client told that, well, I'm supporting conditional responses. So um, if the client doesn't support, it needs to fold either, well, allow, deny, no opinion. Then only output a conditional response if you can't output an unconditional, such that it's easier to short circuit. Only output a conditional allow if the request actually can become authorized. And this authorizer will know. And the authorizer must prune away all of the kind of uh, non-matching branches. So if you have something like um, something and false, then you should prune that away because false, whatever the something in the on the left hand side of the and is, then it will always be false. So things like that. Then be API version aware, not fail open when new versions are added, and then try to use some non-Turing complete language to bound execution time, memory usage, and stuff like that. So these more recommendations are like kind of documenting how we envision people will use it. But then as we spoke about the some of the caching stuff, I just may and then like kind of should the authorizer just like seeing an object, should it just like in phase two just use the object and call us back later. So and we could to some degree, but just to kind of visualize the difference between what it would look like if we consider this one, where we on the this axis, can you see my pointer, right? Oh yeah. On this axis, we have some response that got cached by the webhook authorizer. So previously, for a certain user and a certain request. And then on this axis, we have, so like since, say the caching period is 2 minutes or something like that, since that response that got cached, then now it could be some other kind of the most recent policy store version could give you something else. And what would that then give for the same user for the same request? And obviously on the diagonal here, they are the same. So for example, we cached an allow and the most recent is an allow. So those are the same. But then now, like what is shown here is the kind of, when you execute this against the cached version, what is kind of permissiveness compared to what you have in the current. So like if you cached an allow, your request will get allowed because of the cache. But then actually in the most recent policy version, it would only be conditional, so it would be less permissive than or like then this request is actually getting more permissive treatment than it should have, and vice versa here. Like if you cache the conditional, but then your most recent policy version would be an allow, then it would be less. So, but at least this is symmetric. So this is what we have today, and the conditional here are just kind of showing like that they fit in with this proposal. But then if you had an authorizer which didn't do this kind of as Mo was thinking, for example, like they didn't do this kind of partial evaluation in the beginning, but just kind of figured that do I need more information, or do I have all the information? And in the case that it would just say give me more information, then it would look like this. So basically all of the time, so like, well, the effective it is such that the conditional responses are effectively not cached. So because no matter if you have an authorizer that just responds something along the lines of give me more data, then whatever then it will do the secondary check, and whatever is a current policy version then will apply, right? So these are always kind of like that. But this is, I think, for some authorizers, this might be fine as well. But just kind of showing the difference that like if we do that, then, or if an authorizer chooses to do this, it might be fine. It just means that like effectively the conditional responses are evaluated against the most current version and not cached. Anyways, we had two options that we went through last week. What's written down in the cap of propagating the conditions through SAR, and then we can support, for example, fast in-process evaluation often, but not always, as was described, because in, for example, versions queue scenarios, the API server which has an evaluator might be too old or too new compared to what the authorizer kind of expects the, for example, built-in cell environment version to be. So sometimes it might anyways call back the authorizer. The user could reason about their permissions through seeing them in SalSAR, or maybe they wouldn't. It's the same thing as for rules review, or I forget the API, but that is in kind of enumerating in Cube. It can always be incomplete. So it's, yeah, that's of course a drawback. There, the authorizer can be stateless and easily horizontally scaled. No caching is needed to kind of support these atomic evaluations. And then finally, if you do the kind of pre-computation of or partial evaluation in the beginning, if you have p number of policies and each policy takes t time to evaluate, then the second time you kind of call get the call, then you only need to go through the kind of you only have a couple of few conditions, and then it just takes OT time instead of P times T the second time. So it might not be a lot. I'm not sure. Depends on the authorizer, of course, but that's something. But then on the con side, these are also in the cap, but just for summarization, if we, well, as Mo was like pushing back on, if we do support something in tree of evaluation, we'd need to, well, define and support some language. Of course, we already have WAP and it would be similar. More data would be passed through subject text review, which could lead to slightly increased encoding, decoding of those. Then even though like a webhook authorizer could, like the one of the ideas is that like with this is like a webhook authorizer might not kind of care to support its own like full evaluation framework, but just say that like, well, I'll just offload that to Cube. This works in mostly all of the cases except versions Q scenarios. If the version that the API the authorizer would send to the API server is, say, for example, too old, then the authorizer says, please evaluate, cell v1 for me, and the API server only supports cell v2. Then the API server will call the authorizer back and say, I don't recognize these, so like please evaluate them for me. Which means that like in any case, the webhook authorizer needs to kind of to be complete support evaluating those. So like they cannot really cheat in any case. It struck me that, well, if someone would do something stupid of like having a CRD with spec secret value should equal in some secret thing in their policy, then if we show that those conditions to the user in the self-serve, they would see secret potentially. So that's also something. And then, well, if the authorizer doesn't follow the kind of best practice of not having an unbounded language, then if they did have an unbounded language, then someone would create these kind of whatever conditions review permissions could, well, use the authorizer to evaluate stuff that maybe it shouldn't. So then option two, so what we discussed last week, but a little bit more in detail, how it could be made working with the existing stuff in the cap. There would be two kind of within this, the authorizer kind of falls into two modes. So either it does the partial evaluation just as described in the cap, but then it caches the whatever result, gives back a context key, and to know how long the authorizer might need to hold this partially evaluated result, the API server sends a cache period in the SAR. And this then works exactly as before. Like the authorizer gets a callback, and there's no in-process evaluation. It always happens somewhere in the authorizer. It can do the same OT thing. And yeah, or then what Mo wanted was kind of to have also a kind of easier mode with full reevaluation for those that want that. Then it applies to the latest policy store, but for most cases, I think that would be fine, even though it's slightly different from what Cube does today. Yeah, I don't think people are gonna notice. But then mode one, I have an example of where mode one would be still kind of needed for some of the, like, well, you can choose between these then. The authorizer can fully choose, and the mode would be basically you only respond with the authorizer only responds with conditional allow or conditional deny in the SAR spec, and then, well, gives a context key so that which it gets passed back transparently, so that it kind of remembers which thing, and it might use a context key and it might not. Pros for this, of course, we don't need to define any common language. We can always, so basically the option 2 here is a subset of option 1. So like we can always define more things in the future, of course, but we wouldn't need to do it now, which is fine by me. Then some authorizers are free to kind of implement this kind of just show me the latest thing. Like I don't kind of first mode is like I don't have all the information, give me more information. And then at the second phase, when you have the information, you just evaluate directly. And using this, whatever we call it, authorization object review, I don't know, the user could dry run their permissions against some concrete, here are 2 objects and, or something like create, here is my new object. Could I could I with this concrete implementation create this? And you will get yes or no back. It's a bit more complicated to scale horizontally, a stateful authorizer. But I realized that you can use like the forwarding thing. So if you have context keys that are kind of some, well, they're opaque to a cube, but for the authorizer kind of semi-structured, then it and the replica kind of ID of the authorizer that has this kind of partially evaluated result in memory is part of the context key, then regardless of which authorizer replica gets the request from the API server, it knows what other replica to forward to, which could then handle the request and resume from memory. Yeah, caching is slightly different, but it might not, in many cases, matter. We still have the use case of like users to understand why they have certain permissions, but maybe we don't need to tackle it right now. I'm not sure, or like at least not in the first alpha. We might anyways want to do some conditional language for the read path and or token attenuation, but again, we can do those later when we know what we need there, and then unify. Then one thing that you cannot do with this, but I'm not sure if, or not easily at least, is that in the previous model you could return, an authorizer could return a condition which says in cell, for example, that says perform a secondary check of this. So like, for example, in order to create CSR objects, the authorizer could say, also you need to have this, run this authorized function again with sign, can you sign and this signer name. You can still do it, but just not kind of within the API server directly. It would be of the form that when the authorizer, which could be a webhook, gets a callback, then it would just do another subject access for you for a normal concrete secondary check, which is unconditional only. And then I'm soon done. But as an example, and then I was thinking about what Mo I think said in the first meeting about like, okay, so is there a path forward of doing kind of conditions on impersonation for the specific object? So for example, something like, so again, not that we should do it, but can we do it? And I think we can, even if we choose option 2. I think I figured one way. So if you have a impersonation filter which checks that, so I have a policy which says node agent A can impersonate its associated node, but only to send CSRs with some signer name foo. And in this worst case example, it would not be a built-in CSR, but some aggregated API, or just to make it super complicated as an edge case. Then what would happen first is the subject access for you checks that, can you impersonate your associated node? Node authorizer, which is first in the chain, says no opinion, and then you have some authorizer here that says yes, conditional allow, and only if request is create CSR and sign a name foo. Then the impersonation filter already has the information about the request metadata. so it can do the secondary check up front, and then it calls back the same authorizer, says that, well, can you can this user do it? And then also the second one would be conditional because it says yes, they can, because I see this request is a create CSR, so that's all good. But I still need you to check that, is object signer name foo. That I need you to verify that object signer name foo is true. And the webhook authorizer here saves this residual object signer name equals foo in with the context key def here in memory. Sends back with the SAR response. It says conditional allow again, and says that call me back again later with context key def. Then next thing we go to the actual authorization filter. Now the user changed. So like now the user is actually the node after the impersonation filter, the associated node, whatever that is. And the node has the ability to do this. So then it goes forward. And now, just as the extreme case, it would say that it goes to some aggregated API server. That also does, and to remember the condition. So how do we remember the condition that happened here in the impersonation filter later? Even in the worst case of an old aggregated API server, all of the old aggregated API servers are taking the user info that kind of happens here, like that is transmitted here between them, and they will pass back the same user info when doing the kind of subject access view in their authorization chain. So we can take this context key def here that says kind of conditional, pass it through user info extra here, and then when doing the secondary, or like when the API server front proxy handles the subject access view, it can add it back as a condition, even though it's allowed, but then add the kind of condition from here, so that this is now a conditional allow, and then now we get the whatever condition was here is actually now here and evaluated here, which calls back to the authorizer that was initial. So that's, again, super, like, I'm not sure if we want to do it, but at least it's technically possible, I believe, to do it, even though the point is basically to say there's no loss in expressivity, I believe, in option 2. So yeah, that's
Hey, Lucas, can you go back to the end of that diagram real fast?
yes.
I thought you said that the aggregated API server could be old, so how would it have a conditions enforcer?
So yeah, so if it's old, right, then this SAR handler sees that it's a conditional allow, but then but that this client didn't ask for conditions, so then it falls to deny. So yeah, this shows now if it's new, but if it's old, then this one
you're suggesting that
yeah.
impersonation that was conditionally allowed would output a differently shaped user. So it would be legible to later things that this was a conditional impersonation.
Right. So in a user info extra field.
Yeah. So it makes the resulting impersonated user actually like a different user. So
no, it's the same user, but it just has the additional field in user info
You
extra.
change it's a different
an observably different
yes
user info.
Yes.
Because of the extra field. It bakes the conditions associated with the impersonation into extra pieces.
Yeah. And because this one is new, it also has a new SAR handler, which kind of adds them back. And we know it's guaranteed to call us back this way. Or this is what we said we assume. So again, I'm not sure what I think about it, but it's like at least it's
I'm sure what I think about it. But it's creative. That's bananas. I
I don't think it's necessarily bananas. It's more that I think we would have to make a contract change of impersonation, which is that it is today unobservable outside of audit,
yeah.
basically, right?
Yeah.
And that was by design.
Yeah.
Uh,
As
I don't know how I feel about that, I guess. Um,
Yeah.
it,
So like in
putting conditions associated with impersonation in extra bits of the user that comes out, I agree, at least preserves the data through whatever layers we're going to do anything with that user info. I wonder somewhat about like size issues. Um, as long as this stuff is, as long as these conditions are only in memory or are going through dedicated APIs, like condition evaluation APIs that we're making, like the size isn't terribly bad, but as soon as you put it into user extra and it starts like going into headers uh, to backends, like I don't know, people are gonna write some nutty conditions, I bet, and it's gonna get big and break
Yeah,
headers.
but in this case, like it doesn't like in the if we do the option two, then we don't need to like you actually don't need to put the whole list of conditions things
I
in the user extra. You just put a context key.
I don't think that works. That assumes the callback comes back to the same Kube API server that originally let the thing through. If you've got three servers, maybe the Kube API server that's handling the um,
wait, why does it assume that
Right.
then?
So that yeah, so that's what I said about like yeah, this one like this is why I didn't propose this originally because it's harder to horizontally scale. You would need to, in order to do this, if you're not passing concrete conditions, those would be easier, of course. But like if you're not passing concrete conditions, you might have to cache in your like if you have a set of authorizers and you have multiple replicas, and only one of them has this kind of the memory, in memory here, object signer name foo is the residual kind of that we need to still enforce with a context key DEF. Um, now,
So,
like,
as an aside, right? Like if I was building a system that could not output the cell conditions, so or let's say the cell conditions didn't exist, so this was the only choice for a
yeah,
moment. Simplifies the example.
yeah,
I wouldn't put stateful information in the context, right? I would just say you need to reevaluate, right? So the context would just be foo for all it matters. It doesn't matter, right? And then it would it would not try to tie the first conditional allow with the actual allow or deny. It would just say, okay, I said moments ago that it was conditionally allowed or whatever. Now I'm going to figure out what I think right now, right? So it's not like there wouldn't be any need for that kind of like state propagation.
yeah. So, well, the problem is that like when you if you don't have this, if you don't propagate this DEF context key here somehow here,
Mhm.
then here in the second check you already forgot about which user you were in the original thing. So even though you send a reevaluation here,
You're talking about the in the impersonation case.
yeah, yeah,
Yeah, so I think to fix the impersonation case, we have to fix how we do that with aggregated APIs, right? So today that process is lossy. I think we would have to come up with a different implementation that retains both the original user and the impersonated user separately so that the aggregated API server can effectively redo the proper check.
right. So yeah, like this is the way. Yeah, so like there are better ways than this. I just wanted to show this as a kind of creative way of like not having to wait three releases to kind of understand that the API aggregated APIs were new because this actually fails closed in that kind of scenario of you don't have to assume anything about the aggregated APIs or nor do you have to do a
I
handshake.
mean, but there's ways
Anyways,
around that, right? Like we
yeah,
could have a field on the API service that defaults to
yeah,
off that the aggregate API server has to opt in to this behavior, and we can have the Kube API server check that before it
yeah.
forwards these things. So like there's there's ways to make this safe so you don't have like rollout problems.
Yeah.
Um, I think at
Anyways,
the end of the day, none of
the
this is going to be like simple or easy, right? So
no,
it's going to
yeah.
be complex if you're trying to like have many separated layers sort of understand what's happening.
Yeah. The point was
Um,
not to kind of say that we want to do this. The point was to say that like I couldn't figure out a difference in with the context key and kind of using this thing, like I couldn't figure out the difference between in expressivity between option 1 and 2. That's basically the main point. And using that as an example of the absolute worst case of like what you could have today.
yeah, so I think my complaint would be I don't think mo that last statement on that slide is true. I think you can do it either way with more like different approaches to make it work. I guess in a sense I'm not concerned about it because I really don't want to try to make that work today. I want it to explicitly not work today and we'll solve it on its own just because it just gets way more messy than I think is necessary at the exact moment in time. Like as much as I think aggregate APIs are super awesome and let you extend the server in all sorts of cool ways, the set of people that use them are very advanced and they'll probably figure out whatever they want anyway. Um,
Yeah, but at least this option, like it by just adding this cache period field and the context key, just for any use cases, at least allows the backends to be either of the two modes here, which seems fair.
uh, so I want to be clear. I think I might have been the most like quote unquote negative in the previous meetings. I'm not like against the cell approach. I just want the complexity to be defended well because it is complex. Um, but I think I generally agree with David and Jordan on that there is value in a built-in system that allows for the lack of a call out, especially if we can reuse that system for other behaviors such as the like the token attenuation stuff, right? Like,
Yeah,
so it's kind of fine. Like, I don't necessarily, right? Like, I'm not misrepresenting you, Jordan and David, right? That like you guys just prefer option one because even though it will internalize a set of complexity into cube, we feel like it eventually will have that same complexity somewhere else anyway, so we might as well use it for more cool stuff, basically.
Yeah, I
yeah,
think
and
you.
then, sorry, yeah, go ahead.
It's pragmatic. I think a lot of people will use it to do simple things, but structuring it in a way that allows for opaque conditions as well let's makes complicated things possible, but makes simple things straightforward. From an external user perspective, like it's more work for us, but
I don't actually think it's more work. I think it's different work. Uh, because I think we're saying that one day in the future, we're going to have a built-in authorizer that can leverage this in some way, shape, or form, probably through Cell, right? So like at some point, we'll have to solve the whole like,
yeah, it's
how do
pulling
you,
some of possible future work into the present.
yeah,
But I agree, it's likely that we'll end up there.
okay. David, I think you were trying to say something.
I was saying that I think this would work for many cases, maybe even most cases that I know of, and I think we will be pushed to produce this in tree eventually anyway. Um, yeah, and I would say that the part that I find the most difficult actually isn't this call out that happens. It is the set of checks that happens with the DAG produced by the authorizer chain initially. Like in the case where the condition fails, the first condition fails, how do you go and evaluate the rest of the authorizers? Um, that was the part that I thought was the ugliest. I agree that it's necessary, but I thought it was the ugliest.
Okay. Um, it's a little bit of an aside, but Lucas, you touched on it briefly, and I want to kind of get the feeling of folks on the call. I don't think we would ever remove it. Would we be okay sort of deprecating in place the rules review API?
I'm fine with that. I thought we had already. Isn't it just beta?
No,
It's been
Uh,
going for like
oops.
forever.
I am fine documenting this isn't going to get expanded. I mean, we already have like the non-authoritative Boolean field on the status. It's like, I don't know, these results might not be complete. We should document and clarify how weak of an API it is. Sure.
Yeah, if we are willing to do that, I think the whole like expanding this stuff in ways where our even future built-in one can't enumerate its own permissions just because it's expensive, probably. Maybe it's not even possible, but maybe it's just super expensive. I would just prefer not to try to carry it forward just because we know the webhooks aren't going to reasonably do it. So
I don't think we should try to add to it. We are already in the case where built-in authorizers like node can't enumerate.
right.
So like we're already there. I wouldn't try to add condition visibility to rules review.
Okay. So that sounds good to me. And then um how serious of a concern is information leakage through conditions? I don't really have a good sense for that. Um,
I know that people could do it if they did a bad job, but I'm hard pressed to think of a reasonable use case where if you
If the incoming object doesn't have a people I'm going to fire in 2026 equals David, then let this be written.
failure of imagination. Um,
I like
is it serious enough for us to consider some kind of action on the part of the authorizer where it declares the condition to be user visible?
people can do self-subject like subject access review, self-subject access review have like the status has never it's like booleans. I guess there's evaluation error and reason. So like reason and evaluation error are informational, but the actual decision has always been like boolean, yes or no.
But that doesn't that just that's pretty low information there, right? It doesn't
Right.
tell
Uh,
you necessarily exactly why.
so you're asking, would someone write conditions, return conditions, thinking that no user will ever see them? This will only be visible inside the server and maybe sent back to the condition authorization endpoint I'm providing.
Right.
I, setting the expectation that conditions are not confidential. Any user by default can run subject access reviews on themselves um, and see the conditions you're attaching to their authorization. If you don't want them to see it, you should use opaque conditions.
Yeah, and the API server could have, or like the authorizer could have a flag for that. So like whatever the, like whatever
You can't use
the
opaque conditions
authorizer.
if you want cell, right? So there's no
Sorry.
Like I would just say conditions are not confidential.
Right, yeah, yeah,
They're visible to anyone who can run subject access reviews and self-subject access reviews, and all authenticated users can run self-subject access reviews by default. So conditions are not confidential. If you don't want like someone to see the conditions attached to their own authorizations, use opaque conditions.
yeah. And the authorizer can make it opaque. So like if there was an authorizer that kind of had a flip on every policy of like confidential, non-confidential, then if you chose confidential, it would most likely be more expensive. to evaluate, but the authorizer would be like, yeah, sure.
I think it has to be more expensive, right? Because you're saying you're going to
Yeah.
have to make that second
Yeah.
call.
Yes, exactly. Yeah.
Right?
Uh, yeah, and this then kind of, well, it also then kind of would work if we want to do the read path. Then that could work if and the Bryce. If we build something like this out, then most likely would. And basically, so what I did in the POC already is like I copy pasted the VAP thing, right? And this could pretty much keep doing that. So like we wouldn't necessarily have to have even separate cell environments from between VAP and this. I think it could be the same.
Micah, with your SRC hat on, how do you feel? You think that's a reasonable? I think people give us real nonsense for CV reports. So,
I mean, docs page updates from the beginning help with. I mean, if we have a position stating it clearly, help mitigate some of that.
yeah, I think it's pretty fair to say that a user can learn the policy that applies to them
Yeah.
in some way, shape, or form, if only by probing until they get allows or denies, they can learn a lot of stuff. So like telling them exactly how that would happen isn't super.
I mean, it depends on your expectations. If you think, oh, I'm going to put my secret token in, and like you have to label your objects with secret token equals 1, 2, 3, 4, 5, and now I'm protected because no one knows my secret token. Like,
Yeah.
you just returned it in a condition, and you can see it, and you can craft your object to pass the policy. So it depends on your expectations.
It would be, I mean, it just would be safer to not, right? Like in absolute terms, not saying we shouldn't. I'm just saying it.
Wait, sorry, I
I'm
don't.
agreeing with
What
Jordan.
do you mean? What do you mean? It would be safer to not?
It would be safer not to show users the policy, the conditional policy,
I
right?
don't think how I'm not 100% sure how that would be technically possible since
Yeah.
it's part of the API.
Right.
Like as soon as you make conditions, yeah, if a remote authorizer returns conditions that Cube needs to evaluate, for that to work with the way we do like delegated authorization, it has to flow through subject access review.
I guess I'm meaning the API server's response to subject access review, not necessarily the contract between API and authorizer.
Maybe what if we, do we need this in self-subject access review? That's the thing that all users have access to.
That's more what I'm thinking. Yeah. Like subject access review, yeah, you need it. But self-subject access review, does this have to be there?
An indication that it was conditional, I think, is important. Actually, surfacing all the conditions, I'm not sure. I think that's a distinct question. I don't think we're obligated to put it there. I'm pretty sure something's going to break. Someone's doing something clever with like impersonation and self-subject access review, and they're using it as an authorizer. So we should not make it confusing for a self reviewer to think they were authorized when actually it was conditional. So the self-subject access review status should not confuse those things. But I'm not sure about whether we should surface all the conditions in the self-SAR status.
I think in the KEP, Lucas mentioned it as a pro that a user could understand their conditions. Now I'm not 100% sure. Like
my user-friendly visibility, your exfiltration, like it can cut both ways. It feels like if because the authorizers have the power to do opaque conditions, as long as they understand the implications of returning cell conditions, it's like these will be evaluated. The pro is they get evaluated and it's fast, and you don't have to handle an operational endpoint for condition evaluation. You should only use this for conditions you're happy with users seeing. Like, as long as everyone understands that, yeah, I think it's fine. I'm confident someone will not understand that and will be upset with us. And so the question is, can we make it clear enough early enough that we minimize and avoid people having conditions exposed that they were surprised by or unhappy about? I don't feel strongly either way. We should at least capture that as like a decision to make. Do we expose it or not? And documenting the implications of exposing non-opaque conditions, at least in SAR and maybe in self-SAR if we end up putting it there.
Yeah, I think we can probably like. I'm not sure we have to make that decision like today in that sense of like we can sleep on it a little bit, even though we kind of proceed with the cap as a whole. Yeah, I was thinking about it as pro as well, to make it kind of this whole system more kind of understandable and even VAP, like, if we have this framework that does these kind of things, we could show there, like, I'm not saying again we should, but like one could show also those, right? But with that, because those are effectively deny only authorizers, right? Like if you partially evaluate them, then you get the same thing. So
But
like you could,
we don't give all authenticated users the ability to like read all VAPs in a cluster by default.
no, but I mean that it's effectively the same thing. So now if this is just like a VAP that happens earlier and we let them see that, then
I mean, it's the difference. It's a VAP that explicitly applies to them effectively.
yeah, exactly. But I mean that's what I mean. Like if you could surface the same for the data that we have in map, you could surface by partially evaluating the same information of like I check that all the conditions that apply to you are true, and then yeah, I filled in your values, and here is the exact thing for which your values let the map go through. Again, I'm
I
not
bet.
saying that we should, but like that's the consequence of like being able to. If we wanted to have it as a pro of like users should now see everything, which they maybe shouldn't.
Uh, as an aside, um, we're saying we're going to add a new authorization API, right? The one that does the secondary, the optional secondary check, right?
Yeah, like the
Are we
review, like basically the admission review, but for authorization, yes. Admission condition, sorry, authorization conditions review, I call it. We can call it whatever.
yeah, call it whatever. I'm trying to think, would there be a self version of that we would want users to be able to call?
I don't think so,
So
because
the reason I asked this is right is like the pro of having self-SAR include these conditions is user get a better sense of like what their authorization
yeah,
capabilities are, but it's still not the complete answer for what is the mutating admission plus validating admission webhooks and in tree stuff are going to do. So it's still like it gets them closer to the answer, but not necessarily the final answer.
so you mean that like an API that way you could dry run an object basically, but I guess you can maybe use dry run for that to kind of see what would if I have this object, if I tried to create it, would it get authorized or not? I see the conditions that I have, and now I want to try them with the full chain. I guess dry run works for that without
Right.
another API.
So I guess you would dry run the object you want to do whatever mutation to,
Yeah,
and either would say, yes, everything is good, or
yeah,
no, and here's why it failed. So
yeah.
you wouldn't necessarily get like all permutations of
So
conditions.
in self-SAR you would see them, but then if you wanted to know what what they in practice become, even though they are opaque, you would be able to evaluate them through a dry run. Yeah.
Guess it's okay.
Yeah. And yeah, for the condition, the one that I also put here, like obviously, if you have, if the condition is a C program and the authorizer is like, okay, I'm gonna just compile the C program and run it, then obviously, like anyone which can create those, which should just be system components, but anyone, if you did something stupid like that, but I don't know, the authorizer clearly shouldn't. So, and I think anyone that's kind of got this far of like reasoning about it also
Wait, hold on, hold on.
realizes
So
that. Yeah.
do we so consider an authorizer that has opaque conditions.
Yeah.
Yeah.
So it's gonna get called out. How do you know that you should trust the incoming conditions as being generated by you?
You don't, basically. Or maybe if we, yeah, so like that's the thing of like if it's horizontally scalable without a memory, then you don't know if it was. So yeah. If you
So
have a memory, like you can use the condition like information to actually, understand that if you have some memory to understand that, well, this matches the thing I had, in that I did before, right? But if you don't, then you don't know if it was changed.
it doesn't seem great. I'm trying to think like, so if I have an opaque condition, like basically I have to like sign it into like a jot or something and send that back so that way when I get it back, I can know that I was the one that in the last n minutes signed that condition, so you cannot like reproduce it without me in the loop.
So what is the attack vector of that then, like
So
practically?
so say I'm the conditions I emit could be expensive for me to evaluate in my backend, right? And I don't want someone who can just run a self-SAR to just send nonsense to my backend.
Right. Okay. But yeah. So to clarify, like even though the user sees a condition through the self-star, they cannot actually. No one except the API server should be able to do the, or like no one except your authorizer clients should be able to do this create authorization conditions review. So like a normal user will never do that, only system components. So like even though you would see the condition, you would see something opaque, but the user couldn't invoke it unless they actually run the thing and get far enough. Like run the request and get far enough.
Mm, yeah, I need to think through the code path. If I run a self-SAR, I can get a condition back, but the only way to push a condition into that secondary API is by having the API server call it. There isn't.
Yeah, exactly.
Oh,
And for that you need the kind of system only permission create authorization conditions review, which the API server, well, shouldn't give to like anyone else than whatever authorizers it knows are kind of clients of it. So aggregated API servers and stuff.
okay. Yeah, so it's a separate API. So basically what we're saying is that we don't think that such an API would have a self
No, no, or
because
at least I'm not.
yeah, I mean,
Yeah,
I think what we're saying is that if we did have one, then it becomes really impracticable to have safe opaque conditions because now that channel can have malicious information in it.
exactly. Yeah, and then the kind of it becomes more because if at least if the API server is the one that is calling, even if you do a dry run or a normal request, at least you passed all the things up until that point. So you're kind of in that sense pretty far. You're not just like executing random requests for random things that you might not have access to.
Yeah, I'm trying to think. I guess if we're saying that that's how it's always going to work, then that's probably fine. Otherwise, we probably should have some kind of guidance for someone using opaque conditions and how to make their system safe to them.
You could always do you can just always have exactly one condition, which is just some random context key, some random UID, and then you do the caching behind the scenes, and then you just kind of check that is this what I knew before, and then you do something, and otherwise you don't. So like that's always an option. Then you need to do some distributed cache or something like that, but if you want to scale horizontally. But it's an option at least.
Yeah, I'm just trying to think, right? Like if I'm an implementer of that second auth call API, what should I do to make sure that I am not going to get in trouble maybe in the future? So certainly you could have like an arbitrary condition that is meaningless, like it's just a string that just says just go reevaluate and figure stuff out based on the rest of the input. So that's totally safe because you're basically just ignoring the condition altogether.
Yeah.
You could have distributed state that you fetch. You could have a condition that's somehow cryptographically signed, so you know you created it, so that's also fine. It's just you can't have like, so let's say your backend system is based on like Python or something. So like
Yeah.
you make conditions as Python. You
No.
probably don't want like what is it like sys.eval
No, yeah, exactly.
arbitrary
Like
code, right? Because then your webhook would arbitrarily evaluate whatever code inside the string as
yes.
Python, right? So that I'm not saying people would do that. We just should probably tell people don't do that.
Yeah.
Um,
That's why I kind of added the non. I'll add it to the cap as well, but kind of the extra call out of like non-Turing complete stuff only, please. Like, don't do.
I mean, you could have Turing complete if
Well,
you
yeah, but
guarantee that you were the input of it, right? Because that means it originated from your system.
yeah,
So
yeah,
yeah, I mean, certainly lack of Turing completeness makes
it's
it
safer. Yeah,
safer because you
yeah,
don't have like halting problem and nonsense.
yeah. So,
I also have to
yeah,
drop, and that's going to end the recording. I left a few comments about other bits, just asking for clarity about how stuff flows through the system, especially when we start stacking. Like kubelet goes to Kube API server, which does a subject access review, which then also goes to maybe some webhooks, which do
which
subject
could go
access.
to multiple new webhooks.
Yeah, so like understanding how the condition sets that come back with authorizer names attached, like how those get combined and then handed off and then sort of teased back apart and routed to the right place. That would be helpful.
Yeah, I was actually, so I was, as I was thinking more about it, like I was thinking that maybe I'll just make it a jag, like, like the API actually is kind of in that sense, like we don't flatten them into, like I was first thinking of like taking all of the things and flattening into one list, but maybe just keeping the structure of like as you got them, and then it's at least clear.
How the
Maybe
heck do you encode a DAG into a
nested.
Well, just like a field, like some
Layers.
structure.
Like
Yeah,
here's the authorizer I hand this to, and here's the set of things. But then like within that, it's a authorizer name and a set of things.
yeah,
Like so
yeah,
when you have a webhook that returns a SAR response to Kube API server, and then Kube API server has maybe other things it's calling that it bundles into a SAR response. Like we have this nesting behaviorally. We just don't represent it in the API today because the API just gives thumbs up or thumbs down. But if you're gonna anyway,
yeah. I was thinking as well, like maybe just like showing that more clearly is
I'm not
good.
sure if we need nesting or if we could just flatten
So
it, prefix it. I left a comment. I actually have to drop.
yeah,
So take a look, and we'll sync up next up.
yep. Thanks.
real quick, Jordan, feel free to drop, but make me host or
Yeah,
whatever you do, so that way it doesn't kill the meeting.
Yeah. Where are participants? All right.
okay. See you, Jordan.
So real quick, Lucas, Let's sync on this together on like one of the whatever Slack channel is appropriate with like
Yep.
the four of us. Um, since next week is a like kept freeze, I believe, right?
Yep. Yes.
And technically tomorrow or today is PRR freeze, whatever. Um, I haven't read your update since the first time I read the cap, so I'm a little behind there. But that aside, I I'm getting the sense that between the various leads, I think we're pretty comfortable making some progress towards this in the release. I think what I would like to start trying to enumerate is, like if we got the kept MERS, what would be like our goal for 136 for what we can reasonably accomplish. And it might just be a bunch of like pre-refactors to start restructuring the code so that future changes are like more mechanical refactors first, so
Yep.
that way then future changes are like less atrocious to diff and stuff, and that's fine. But I think we do need to align on that so that way we can make sure we have enough review time between various folks to get it in. And I will say I'm foolishly making the assumption that you're planning on implementing a bunch of stuff.
Yes.
That's not true. That's also fine. You don't have to do that. It's mostly let's just make it clear that,
Yeah, no, I can, yeah, I plan to take a stab at getting the intent thing, or yeah, further than. So I had like the POC, which of course is a good start, but yeah, there's more stuff that has happened since I did that, so there's more to implement.
yeah.
But yes,
Yeah, I think if we make some forward progress, I think it would be nice.
yeah, I think like at least for myself, getting a kind of end to end. The goal for me would be to get a full end to end like stuff working in during this time with everything refactored and stuff. If it can make the code freeze or not, I'm not sure. Maybe just the pre-refactor of the interface does. But at least getting the kind of to that point that we can feel kind of confident in what it's doing uh, would
Yeah,
be
so for
would be
me,
good.
I think minimum is just, if we can get alignment enough on the kept that future progress will be made in future releases is like the minimum. I think we were pretty
Yeah,
close to that anyway, so I think it's fine.
yeah,
I
yeah,
don't think we're gonna miss that. Otherwise, I think I would be pretty satisfied if we just did whatever prereq work to get things rolling. Um, Not necessarily for this release, but I think it would be good to start reasoning about the stuff Bryce is looking at.
yeah,
Um, like I think what ends up being that if we decide to go down the route of using cell here, it makes most sense to try to use cell in the other place too. What that means is realistically that we would not be able to use biscuits as is, right? Because we would be sort of
yeah. No,
limiting ourselves to cell and not data log. I think that's fine. It's mostly just a matter of figuring out, um, well, what are we gonna do there? And
yeah, no. I think it's also like yeah. Let's see kind of how it goes down, but at least it would be nice in the sense of like if we say that well we support cell here, we support them in WAP, we support them in authorization config and whatnot, and in token attenuation and all of these kind of things. At least then we would only have one language,
yeah,
which would be preferable. Like the core runtime would only need with all of the evaluation and logic and partial evaluation and stuff would only need to be written once at least.
yeah, I don't think there's realistically any way of us picking something other than cell for built-in stuff at this point, just because how much effort we've already put in, right? It just
Yeah.
like even if you ignore the effort, I just don't want to try to explain to like users like, hey, by the way, there's now this other language that you have to learn, even if it's like way better or something. It's just
Mhm.
there's only so much you can ask users to understand. So I think cell is pretty much going to be the way. Um, I did remember a question. I don't know if it's addressed in the cap. I don't remember seeing it in the cap. So I think for the most part, we're fine in the sense that these cell conditions are coming from trusted places, like the authorizer is like a trusted
Yeah.
entity. Right? Um, for the I think the answer then means that if you return cell conditions, we don't have to do cost analysis. I think that's what that means.
Yeah. If we can. So actually, yeah, if we can trust the authorizer to not do like bad things, yeah, no, we wouldn't. I think so. One thing that I did have in the like early revision as well was that like there would be basically two modes that you could return conditions, or like one human readable, like that you could give to self-star and stuff like that. Maybe we don't need to implement that in the beginning if we don't like to. But one optimized, so like you would. How do you feel about like returning the ast like as is? It's like binary encoded somehow, and then you wouldn't need to parse the string like in the hot path of like authorizer did something, it knows about the cell, it has the cell, now it just gives the ast, and then evaluator just takes the ast and evaluates, doesn't have to, because otherwise compiling could take some time of
Um,
like the condition.
I am not familiar enough with the AST evaluation of our cell stuff to know if that's like guaranteed to be safe. Like, I know the if you take a cell environment and you execute a cell function in it, that has some pretty strong guarantees because you convert the textual representation into the AST and then evaluate it, right? So like you're going through
Yeah.
like a trusted translation. I just don't know if it was ever designed with what if you skip the first step and just
Mm.
throw in the AST, is that like quote unquote safe? That would probably be a good question. I would say if we went down that route, it would make most sense to only support, like, let's say it's safe. I think it would probably make sense to just only support authorizers sending back the AST, and then the API server can convert it back to textual if it makes sense to in the context. Maybe.
Yeah, actually, but that was the hard part because there is no like simple mapping from AST to textual. I tried it. You
Oh,
need to have there's a separate struct source info. So then you need to kind of basically tell like if you have that a separate thing, then you can do the conversion back
I
if
see.
you're lucky. Because basically source info tells the macros are expanded in weird ways. So like everything, like you have
Oh, so it's like a
a
lossy
for
translation, but
yeah, if you have a for all translation, you don't know that it was a for all translation or like that it was a for all macro. It just kind of you can reverse engineer it a little bit. I tried, but then that is not good. So like if you want to go back, then you need the source info, which basically says that at ID AST node ID foo like 5, then there was a for all. Um,
hmm.
but yeah, like in any case, like we could support the optimized first, and then yeah, it was clearly we can't show that to users because it's like,
Nonsense.
yeah.
Um,
um, but
Yeah. So the reason I was thinking about the whole cost stuff is right, like you were saying that this kind of like VAP. The thing about VAP though is that VAP lets you call the authorizer via the authorizer function, right?
yeah,
So I'm curious if we think that should be supported, that like you can
yeah,
return a condition that basically says, hey, you also got to call me back because but then that becomes a little weird, right? Because you can control the inputs of that VAP with arbitrary data, I guess.
yeah.
And then can that return a condition? I don't know.
No, so yeah, that would be supported, but that second check would not be conditions aware because like the in the same way as we said, the VAP use of the authorizer is never conditions aware, or
Oh,
like for now, never conditions aware.
yeah, for
Yeah,
this
yeah,
effect, right? So yeah, so
yeah.
those would not be condition aware, but we are saying that we would allow it.
I believe that's what I wrote in there, but like I didn't get any, or like I thought I said maybe I said it in a weird way that people thought it was other things. I I don't have a specific preference, but is giving you parity with VAP, and then it's not, avoids the kind of extra call out in the sense of like you could do it. So say that you did an opaque condition, then you get callback, and then say that your condition there actually requires a secondary check. Then the webhook authorizer anyways would need to do a SAR separately with just like on the sign certificates, signer name something resource, for a CSR create. And then it did that, and then because that authorizer might want to respect the whole chain and not just look at itself, right? If it knows it's the only authorizer, it could pre-compute the value of like do I allow this user to use this signer, right? If you don't, then you need to call the whole chain, and for that you need either to have like authorizer variable in the cell environment that you return, and then at least it's fast because it's inside of the or fast-ish because it's inside the API server. Um, or then you implement it through an opaque condition and actually performing a SAR, if that's what you wanted to do. I think it's not worse or any worse than VAP using the authorizer.
Yeah, I'm just trying to think. So in VAP, we basically only allow you to use it once. Like you can't keep calling it
Yeah,
many times. So I think that we need to maybe think through, but like the CSR case, I think is pretty compelling, right? Because
yeah,
that one would let us like as an aside, right? Like um I know it's implemented in admission, but like I think if we went back, I would push pretty strongly for it to be implemented in the REST layer instead of admission because I don't think like it to me it's never optional, right? Admission is theoretically optional.
yeah, yeah.
And so if you look at how we did DRA admin access, David and I pushed really strongly to
Mm,
put that into REST because we did not want we wanted the authorization check to always run. And if a cluster admin decides to say everyone can do that, that's totally fine. But they don't get to pick does the authorization happen or not. They only get to
yeah,
pick
yeah,
who's allowed to do it. Um, so it would be nice to be able to return like a conditional allow saying, hey, you need like if you change this field,
yes,
then you need to, well, I guess we don't let you change the signer. So for CSR, it would be like on create, you need this permission on
yeah.
the signer name.
Something that and that's actually the very similar use case that I was talking to Tim Hawkin about when I kind of just pitched him this idea, was that he was kind of looking at this from the perspective of I'm an API owner, or like like I make an API, right? Someone, and then like now I want to enforce secondary checks for this field always. How do I kind of express that, and how do I kind of you know do all of those things? And then of course VAP is the answer that we have now, but at least if this is consistent, if the way we do it is consistent across admission and authorization, and they kind of become more uniform, then um, it's easier for both sides to kind of reason about that. Okay, this secondary check is done always for this API.
Yeah. Okay. So yeah, I don't I think we should figure out how to call out the whole cost stuff, even if it is we assume API server trusts the authorizer highly, and if it wants to return expensive to compute cell operations, that's on the authorizer to guard, not the API server. I think that's an okay statement. Um,
Yeah, it's I guess the only thing, yeah, because it's like
I guess it'll become awkward for us if we build RBAC++, right? Because then we would be saying that REST API somehow has to enforce cost of those resources.
yes, but we already did for VAP crates, right?
Yes, but VAP is effectively cluster admin only.
Right, but I
Cost
mean the
analysis
check is
for
there,
VAP.
like that you don't exceed your costs in the
Right.
HTTP handler. Yeah.
But that cost analysis is purely to protect the infrastructure from the cluster admin. It's not really there to protect from like regular users, right? So basically, there's no realistic way for like an admin persona for a namespace to influence the cost of the VAP because they can't create one because they're cluster scoped.
Yeah.
So if we had a role and a role binding equivalent in this RBAC++ world, which are namespace level scoped, what what mechanism do we use to make sure that those people don't do anything insane? Um,
Yeah, it would maybe lower cost, nor a bit, yeah, quota.
maybe something. The other aspect of that would be figuring out like maybe we can cheat and just say that this built-in one still would only support no opinion allow and conditional allow, but it wouldn't support any kind of deny semantic. Um,
Yeah, like that is at least a good place to start. So what I've been looking into is also like, and this actually, yeah, this now goes back to the very first presentation that I did about this, where I kind of was wondering that, like, should we even have loops at this stage? Maybe not, right? Because they, at least then you can do a lot, right? But you can't index deeply in the objects. So um, then you are way safer in the sense of, and then that, as long as you don't have loops, you could also check in a fine-grained way for privilege escalation. It's maybe not something,
can you hear
or
me?
for deny policies that is actually useful, very useful, to make sure that you can't kind
Oh,
of,
hold on. Can you hear me, Lucas?
yep.
Uh, so I think my internet blipped for a second. So literally the last thing I heard was it goes back to the first presentation and then you just froze. So I have
Okay.
absolutely no idea what you just said.
Sorry. But yeah, now hopefully now it works. First presentation when I was talking about that, like how expressive do we want the stuff in authorization to be? Because if we don't want it to, or like if we want to do stuff like deny policies, then it's really like cool to reason about that. So for example, I'm a namespace admin, and maybe I want to be able to deny people, you know, um, access to stuff inside of my namespace, but I shouldn't be able to lock out the cluster admin, right?
Right.
So then you would, if you can compare two policies, then like, is this policy set larger than the other one? Then you can check that the namespace owner never denies anything that they shouldn't. Like they have some space of like things that they can deny, and those things that they can deny are always within their namespace, and never selecting the cluster admins, right? For example.
Okay, hold on. Like, how would that work? So I'm a namespace admin and I put a deny rule saying that only I can edit this config map. How would
Mhm.
we say the cluster admin is still allowed to edit the config map?
So through, if you have like because if you have a separate kind of set of permissions of like, okay, so you have some set of permissions which you're allowed for, right? And so the admin is allowed to do stuff within the namespace. But then from somewhere, if you had separately the deny privileges, then the cluster admin, which gave you, the permissions in the first place, both the allow permissions and the deny permissions, would say that you can, I allow you to do anything within this namespace, but I allow you to deny everything within this namespace except locking me out. And if you can compare two policies, you could prevent the kind of ability for the namespace admin then to lock the cluster admin out if the cluster admin said that don't lock me out. So I have a write up on, let's see. in an issue on GitHub.
How does the cluster admin express don't lock me out?
Um, Let me pull it up. See if I even remember it myself. To explain it in some good way. So here, and see how involved was it. This is showing the actual math behind it, but let's see. So an admin setup root access or like access to principal Lucas in the namespace Lucas NS. Okay, so how would that look like? Permit any action for Lucas when the namespace is Lucas NS. Okay, that's just the allow rule of letting me do stuff within there. Then I say that allow Lucas to deny things within this namespace, but then don't allow Lucas to deny anything which touches me. And with that, the Lucas within this namespace would be able to say that forbid list and watch secrets in my namespace. As long as I don't lock myself out, which would be one of the guarantees, right? That would be awkward. And then as long as the group isn't admin. So like
So that
this
first
this
one
kind of
isn't guaranteed, right? Because I could forget that first condition and lock myself out, and then the admin would have to break me out.
no. So like if you have the ability to compare two policies, then you can do this automatically using automated reasoning.
Wait, hold on. What am I comparing?
The spaces of the like what are all the possible variable assignments, and then you want to check that. Let's see. You want to check that if the deny rule matches, then the requester, whoever like sent that deny rule, actually has the ability to deny that thing. And the same, the second thing is if the deny rule matches. So for all of the things that where the deny rule matches, then you're also kind of you block yourself out. So it's similar to the visual representation of it. I should actually do a visual representation. Let's see. Which one was it? I think it was this one. So some of the first presentations. I need to go and actually, like this is what I wrote up in a thing that I think could work, but so I haven't formally verified this or anything yet. But it's similar to this. So like, so it's similar to what I did for the lead path with this. So like, you have a set of selectors coming in, right? Or like you have a read request, there are some selectors. And now if you if you had the user write this thing, instead of writing in R++ something like this, you would like them to kind of reason about the policy in the exact same way as they do for a write. So like I see an object, I tell is this object good or bad, right? But then so here is a sample visualization of the after you do partial evaluation, you have some space of like object that you could access. Like here visualizing the kind of owner dimension or like kind of variable. What are the different values that the owner variable takes? And here is what are the environment like values that the environment variable would take. And then if we see here, then like label is not prod and label is team 1 or team 2. So like not prod, so that all has to be kind of red, but everything, all other environment variable like values are okay. And then as long as they're also team 1 or team 2. So that's this thing. Or then labels envis test. So like that's this. So now this is my then authorized space. And then I see a label selector coming in, which says owner in team 1, team 2, and so either these or test or dev. So that kind of selects these different possibles of concrete instantiations of the object. Now this is authorized because whatever is, yeah, actually I have a better slide of this somewhere.
A quick
Whatever,
aside, this
yeah,
this isn't supported by Cell, right? Like you can't.
no, but so CDAR has a like so Cell and CDAR's. I think I had it here somewhere. Yeah, like the overlap is basically everything um, except loops. So like as long as you don't do loops, like in weird ways, you could. It's a probably a lot like it's a lot of work, most likely to do it from like Cell. CDAR did it. So like basically translate all of these things into math. And if you have a simple language, it's easier to do. And then then you can say that, well, for all of the possible things here within the box, it has to be such that you're authorized. But in this case, it would not be. So like this would actually give you a concrete counterexample. Um, oh yeah, here I had it. So like so you say that for every object, whenever the object is selected, it has to be authorized. And this needs to be like always true, this thing. If you do the negation of this, it's easier. So like you ask a solver to find a counterexample where the object would be selected, but it would not be authorized. And in this case, you can't find a counterexample, so you're authorized. In this case, you actually do find from the SAT solver or SMT solver, you find that, well, there is a case where you would be selected but not authorized, and that case is when dev, like envis dev and over is team 3. So like you could use the same type of thing, I believe, for figuring out like comparing policies, like the deny policies as well, to make them actually,
Wait, hold on. So if we
useful.
can't do this with Cell, we couldn't do it in Tree, right?
Sorry.
So I think we're saying in Tree we would only support Cell,
I guess, yeah.
right? So that would mean that the in Tree RBAC thing we could not safely support deny semantics on a namespace level resource.
If we allow that RBAC++ thing to do loops, no. But if we restrict it such that
Can you go back
you,
to the little diagram that had the, I'm trying to remember what you can't do.
so yeah, so CDAR, so basically all of the normal things you can convert to SMT language, but the loops you can't really. So like if we say that this is the supported set of things, um, then we can use
I don't think we can though, right? Because there's just too many lists in our APIs that people need to loop over and maps, right? Um, like you can't set this label. You can't like I loop over this list and make sure that you can't do XYZ within the list.
yeah, I mean it's all about like how deep do you wanna how deep do you need to nest the thing? It's about like also what you said about like the cost. Like if we restrict it to this set, then we can be fairly certain that the authorizer never gives us a thing that is insane. If you allow loops or string concatenation or all whatever different things, then you could have a very easily kind of an unbounded, or like at least not unbounded, but like exponential uh, tree of
Would
things.
it be possible for a policy that can only allow to support all of cell, but then the deny policies only support the subset?
Yeah, maybe uh, at least to some degree, I guess.
Okay. I think
What
that's
I yeah
probably what is probably the limit of what we could achieve, right? Like first we would have to even decide if we want to support deny in tree at all.
yeah
Like I would argue that we got really far with RBAC not supporting it, and the cell stuff, even with just pure allow semantics, is really powerful. Um, so maybe that's fine. Um,
yeah I don't know, but it's been very interesting to kind of look into the kind of like if we would, then what would it look like? And I think that like yeah, it would be very hard to do it in any other way than actually having something to kind of prevent for of the privilege escalation of those kind of things. Of course, we could have just to like say that deny rules, only system masters can author deny rules, but then then like all of the it gets what is the utility then for normal people? I'm not sure. Um, so
yeah, I mean, I guess we have to be really careful in this sense of like even if the deny rules are only supported at like the cluster admin level, um, we still need to make sure they don't brick themselves in some nonsensical way. Um,
yeah, but I think that like well, we can as we kind of go on and check the specifics more on like what does the condition that we would support in tree look like, then at least starting with this set or like using this supporting this set initially is at least much safer or like relatively safe compared to allowing loops as well. Like if we want to do that, then I mean we can, but then we lose some of the kind of abilities of checking what. Even that is like I saw that one of the
I
um,
think the problem just becomes that the stuff on that left side is too important for people's needs, right? Like regex style matching and looping, I think, are pretty fundamental to what people want to be able to do as policies.
yeah
Um,
they are, but yeah. So here is if you're interested in seeing like how it actually compiles, here is an example of like they take CDAR policies, which yeah, which the intersection with cell is like huge, um, and then compile them down into this mathematical language, and then the solver um, well solves. And of course, if that thing in the worst case has a exponential runtime, like in the very worst case, most often it's linear, but like the theoretical worst case. But this is something you would do on writes, so it's a little bit same as cost checking. Like you wanna, and I'm not sure. Maybe the exponential thing already in RBAC privilege escalation. I haven't analyzed it, but anyways, like for these kind of privilege escalation checks, I think it's fine to do something like that more complicated. Then what other things it does, which is nice, is that well you can now kind of start reasoning about if two sets are different and these or like if you have one allow and then you have another allow which kind of shadows it, why do you have the inner allow? Like makes no sense. Or if you have a deny rule which is kind of you didn't realize that it always select the smaller one, then that's also a thing. But I think maybe um, uh, as we like I put it on the last thing for the presentation that I shared today. But yeah, like if we did some RBAC++ thing most likely we would keep the core structure of what we have in RBAC already there. So like, you need to enumerate the resources, API groups, verbs and stuff like that. And only if you um, and if you want to match against star, as you said, like then you need to write a star there so you don't forget about it, but you actually were kind of intentional about that this should have wide coverage. So like it can be a hybrid in that sense that like some of the things is very easily analyzable, right? Like how big of a space do you select, and then the fine grained stuff is maybe doesn't need to be analyzable because the kind of outer thing is so like you have the small the loops on something in your object we would support it, but um, and we could even analyze everything else but that. Yeah, those are some interesting things that you could do with these to kind of actually give the user a better sense of like, am I doing something stupid or is this that like does the RBAC plus plus linter like succeed type of thing.
Oh, as an aside, I meant to say this earlier, but then I forgot. So I did do some digging through AKS logs.
Mm-hmm.
Um, I know there's some amount of double counting happening because of that, one request can make many audit logs um,
Mm-hmm.
because of how the state transformation happens. And I haven't come up with a good way to deduplicate because it just creates like really high memory pressure on the RBAC
Mm-hmm.
infra, and it correctly says F you to me and tells me to go away. Um, uh, but ignoring that minor double counting, um, for write requests, um, considering like many billions of events, something like 99.98% were allowed to
Right.
go to admission.
Yeah,
So
that's
I
a
think
lot.
that's where that goes to my like thing where I was pushing back on David a bit about like it doesn't really matter if authorization is cheap because for the vast majority of write requests, you have to go to etcd and pull the thing out, or your cache or whatever. You have to unmarshal the whole thing and you have to run it through admission, and that may or may not succeed. I didn't check that far, like what percentage of those that make it through then succeed versus fail. But at the end of the day, I don't think it super matters. The point is that the cost of a success and failure isn't super different at that point because you've already done the really hard work of basically fully rehydrating all the objects
Mm,
to make those decisions happen in code. And at that point, like, okay, sure, maybe if you have a ton of webhooks, like admission webhooks, yeah, that could get expensive, but that's that's not the default state, right? Usually people don't have a bajillion of them that apply to every object. Um, but that aside, so I think that is sort of worth thinking about how we're considering this whole system, right? Like we're like, yeah, this first phase has to be really cheap. Um, I don't think it really matters at all if it's cheap because the vast majority of requests on real production systems actually make it to the second layer. Now, I don't think that negates the benefit of the first layer just returning cell conditions because then it's not like an expensive call out. So I'm not saying it votes against having built-in cell condition response. I'm mostly just curious why we insist on keeping authorization so cheap when the reality is it doesn't actually matter in practice.
yeah, I guess maybe yeah. So one thing is I guess that you can cache that as well. So like if you have like lots of like you can't cache the result of a admission something like the second stage you can never cache, but at least the first stage you can. So like if you do repeatedly lots of um whatever node does something about leases or controllers do some stuff, at least those can Um, those can be fast. You don't need to reevaluate them all the time. But you couldn't if you do something animation. You couldn't do that. But yeah, like at least now like you do a little bit of work and in both stages. So like you split it in that sense. Like you don't need to reevaluate everything in the second stage, but you did some of the work and it was fast in the first stage, but you already what you did you can benefit from in the second stage. So you don't at least have to do it twice, which is nice or an added benefit.
Yeah, I wish I could quantify that. Like, so I think I understand what you're saying, and I think I agree that it is that caching is valuable. I think what we end up saying though is that um, for write requests, um, it may not be as beneficial as we might hope, right? Is that like the most like basically if you consider two requests, right? One where the authorization response was cached and the return conditions versus one where it wasn't. The only thing different in cost is figuring out the conditions, right? But you
From
still have to get
from the authorizer, yes, like
right,
in the first
but you
stage,
still
yeah,
have to get the
yeah,
object and reapply it and everything, right?
yes,
Because you cannot cache the application of the
no,
condition
no,
once the
yeah,
object.
no, exactly.
Um, yeah, I'd be kind of curious what the percentage of that
Yeah,
ends up being like.
if you have a percentage of like even just reads to writes percentage of that, I guess you should pretty easily be able to get, or then like hit cache.
No, I'm
I
not
guess
worried
you,
about reads to writes. It's
yeah,
like, what's the difference in cost of write requests with or without the conditions having to be cached? That's the difference, right? That's the delta we're
yeah.
talking about.
Do you have like do you know the cache hit rate of the clusters that you have? I guess you run an webhook authorizer, or
I don't think
you
we
don't?
keep metrics on cache hit rate.
Yeah,
Uh,
yeah, maybe Cube APSer doesn't give you that.
there
No.
are, well, no, there are some metrics for webhook authorizer. I can't remember exactly what they do, but even if you have, I don't think the metrics would capture the cost, right, of what exists. Like the condition concept doesn't exist today, right? So they, but yeah, I think that's what I'm trying to reason about, right? Is that like on the average, let's say to do the fetching of the object from etcd and deserializing it and looking at the body of the payload and deserializing it and running any mutations and whatever, those steps, right? Let's say they take, I don't know, 100 compute cycles for some
Yeah,
crazy thing, right? How many compute cycles is the authorization step? Is it like one or is it 10 or is it 20?
it should be fast, right? Like, or like it feels like it would be, I don't know, five,
Well,
10.
no, so what I mean
Yeah,
is like,
yeah.
are you saying it's fast when it's cached or it's always fast?
I believe that it's most likely always pretty fast. Yeah.
Right. So
Like,
for
oh, well,
performance,
linear in your policy, like RBAC objects, like how many RBAC object size, but could be even sublinear. But yeah, like I think anyways, it's probably always pretty fast. Yeah. The only thing is maybe if you have a webhook that is far away or something like that latency wise.
trying to think though, right? So like, how does that translate? Like,
So yeah, so let's say in another way, like I don't expect it to be a much or any worse than what we already do today with, like the RBAC authorizer just like, literally looping through every binding and these kind of things, right? Um, and then yeah, like I expect the deserialization and all of that kind of stuff to be anyways like the biggest. kind of be the most significant factor in like the total request time compared to anything that happens in authorization. Or at least that's the hope. Maybe with the authorizer cache now, like that everything is consistent in like you don't have to go to etcd, right? In many cases. Maybe that changed so that part is now so cheap as well that like you don't so that everything else becomes more significant. It could be.
Yeah. Yeah, I guess I don't think we can reasonably necessarily collect the data on like what that looks like because I don't necessarily think we track it well enough to
Yeah, so I checked that at least there is. I don't know if it says anything about your case in that sense, yeah, but at least there's request latency and those kind of things, but they don't tell you about the cache for the webhook authorizer. That is,
Mhm.
um,
I
but at
gotta
least,
drop.
yeah,
Good conversation. Let's see if we can. I think our next meeting is right before code freeze, right?
yeah. I was thinking like so. I think PRR I got a on the cap issue as well. Someone from the release team saying it's okay, so I guess it's okay. Like that I did all of the PRR. I just filled it in. There wasn't
Yeah, so
too
for
much
alpha,
applicable. Yeah,
basically just try to fill out as much of the PRR as you can and make sure you have the PRR file and the kept.yaml file in a reasonable state, and it's fine for tomorrow's deadline or today's
yeah.
deadline.
I
So I
think
think that's
just to be sure, I'll also based on this discussion today, which seemed pretty, like the people were pretty happy with it. I'll also make it put the state to implementable just to make sure that no one is, like complaining about that because it's implementable in the state that like we should go and I should go and try to figure out as much as possible of like, how to how to make this all concretely
yeah. So I
propagate
agree
through
with
the
that.
system. Yeah.
Let's get an act from David and Jordan. That way
Yeah.
there's no disagreement. I highly doubt that they would disagree, but let's just
Yeah.
make sure we're on the same page.
Yes.
Yeah, and let's see what Jordan and David think are good code level milestones too for this release. If we can start nailing those down, I think we're in pretty good shape.
Yeah. I'll follow up on the issue and then like start a Slack thread just to make sure that they agree with that assessment. And then yeah, I think we can. Of course, I could always now that I know it's close to the final shape, I could always go and clean up. Try to make it a little more shorter the
It is pretty
document,
long.
but
Uh,
now that I know where it ends, then that's easier to do. But at least maybe I can do that also later so that we just can
I
put
mean,
the approval and
kept
all
are
that kind
living
of,
documents,
yeah,
right? Like
yeah,
you're supposed to keep them updated with the implementation over time, at least until the feature GAs,
yes,
and maybe the kept goes a little stale. But yeah, so I wouldn't say that whatever we merge has to be perfect.
no, yeah,
Um, so I'm not stressed about that aspect.
yeah, I know. So then at least for the enhancement fees we're good. But I'll start a thread to just make sure that we get the thing tagged appropriately.
Okay, sounds good.
Cool. Yeah,
Thank
thanks
you.
for the extra hour as well.
Yeah,
It's good
yeah,
to have some synchronous time. Like, yeah, doing this through GitHub is way slower.
it's untenable for anything this complex. It's just
Yes.
not practical.
Cool. Yeah. Have a good day and see you.
Started.
Bye.